Welcome to the video for skill number 81 for Geometry, Unit 11. I can find the area of sectors and length of arcs. And I'm going to add to this also the area of segments. So we're looking for the area of sectors, segments, and length of arcs. We'll begin our notes on page 81A. And if we're looking to find out the area of a sector of a circle, we should first start with defining what a sector is. So a sector is a section of a circle. We trap it from the central angle and we're looking at the shaded area. Whereas a segment, we take that area and we draw a chord connecting those 2 points and shading that in. So what we have here is the area of a sector is equal to the area of the circle times the portion that is the sector, which makes logical sense. The area of a segment I didn't write down here, but I will shortly. It's going to be the sector area minus triangle area. So, example 1, we're asked to find the area of the shaded sectors, and in the first case we're given a radius of 5, the arc measure of 130 degrees, so we just do pi times 5 squared times 130 over 360, and we get approximately 28.36 units squared. In the second part we have a sector that is greater than half the circle. But the formula still holds. We do pi r squared times the measure of the arc over 360. And because our arc here is 120 degrees, that means the arc of our sector is 240 degrees. This yields an answer of approximately 134.04. In example 2, we're asked to find the area of the shaded segment. So what we have is a 90-degree arc, and the chord that connects those 2 points defined by the radius, and we're looking for the area of the segment. And we can find the area of the segment by taking the area of the whole sector, and then we're going to subtract out the area of the triangle. So the area of the whole sector is the formula we just practiced, pi r squared times m over 360. And then the formula for a triangle is 1/2 base times height. So we plug in the values pi times 4 squared times 90 over 360. And then our triangle, because it's 90 degrees, we know that the triangle is a right angle, so our base is 4 and our height is 4. If it were not 90 degrees, we would probably need to do some sort of right angle or triangle trigonometry type operations, sine, cosine, and tangent to find the height. So area of sector minus area of triangle, and we get the segment to be approximately 4.57 units squared. And the final piece of this skill is finding arc length, and we can find the arc length using the formula 2 pi r times m over 360. And what we're saying is if we have a circle and that circle has some sort of angle inside of it, starting at the center, the arc length is the distance that is covered right there. So example 3, we use the formula. It says find the indicated arc lengths, and we're looking for arc AB, and this is a minor arc that is 45 degrees, and we have a radius of 7. So 2 pi r times m over 360. We substitute 7 in for r and 45 for m, and once we calculate that out, we get that the length of the minor arc AB is approximately 5.5 units. In the second part of example 3, they're asking us to find arc DEF, And DEF tells us that we're looking at the major arc. And if we have 140 degrees on arc DF, that means on arc DEF we're going to have 220 degrees. So when we plug it in, we go 2 pi r times 220 over 360. Plug in 11 for the radius, and we get the major arc is approximately 42.24 units. And that's a length, so we use units rather than units squared. Alright, for this video, the key ideas and concepts rely on your ability to find sector area, segment area, and arc length, and being able to recognize what a sector is and what a segment is. Sectors are portions of a circle, very much in the kind of pizza slice idea, and the area of a sector is equal to pi r squared times the measure of the angle of the sector divided by 360. The segment, a segment is going to be a circle with a sector in it and then also the chord, and the segment is the area between the chord and the circle. And we find segment area by taking the sector area and then subtracting the triangle area. And we need to remember that the triangle is going to be 1/2 base times height. So sometimes, usually we have the base as the radius, and the height is going to depend on what sort of angle we have here. And then finally, we need to be able to find the arc length. And arc length is, if you have a circle and the arc is right there, we want to figure out that arc length, and the equation for that is 2 pi r times m over 360. So for the observer, the observant observer, circumference times the portion of the circle, that is the arc, and area times the portion of the circle, that is the sector.